Hello, everybody, and welcome to Crystal Case Studies. This is the place where we deep dive into crystal geology and mineral science. My name is Emily, and I'm a geologist. And today we are going to be looking at apophyllite, specifically the apophyllite we get from the Deccan Trap formation in India. Before we get started on today's crystal, it would mean a lot to me if you followed and rated this podcast. A large percentage of my listeners are not currently following me, and podcast platforms use that metric as a really important way to calculate how popular a podcast is. So it would mean a lot to me if you can quickly hit the follow button, as it helps me massively with the content that I can produce and the guests that I can invite on. If you are an enjoyer of crystal geology, crystal science, of minerals, or if you're a crystal seller, you use crystals in your craft, or perhaps you're just a crystal enthusiast, this might be the podcast for you. You can follow me on social media under @crystalcasstudies to stay up to date with all of my crystal geology content, and let me know if you want me to cover a specific crystal or stone. So today's crystal case study, we are going to be focusing on apophyllite, specifically apophyllite from India, and the apophyllites that come out of Maharashtra from the Deccan Trap geological formation. This is a really great case study. This is the first case study I ever did. I did this as a talk at the London Gem and Mineral Show last year, and we're going to be touching on the dinosaurs, volcanic eruptions, some really interesting geology, and there's even an at-home science experiment that you can do if you are willing to sacrifice a small piece of apophyllite. So in this episode, I will be referring to fluoroapophyllite as apophyllite. The apophyllites are actually a group of minerals. They're actually, it's called a solution series. So there's a kind of range of minerals that are the apophylites. And the one that I'm going to be referring to as apophyllite is actually called fluoroapophyllite. This is because it has fluorine in it. And this is the one that is most commonly sold on the crystal market. If you've bought apophyllite, it's probably fluoroapophyllite. And it is those distinctive, transparent to white, pinkish or greenish, four-sided prisms which end in four-sided symmetrical pyramids. This apophyllite is often very glittery and is often found and sold with other closely associated minerals which form in the same area, such as zeolites, quartzes, and calcite. So as I've just mentioned, fluoroapophyllite, as the name suggests, contains fluorine and is a hydrated potassium calcium silicate mineral. The apophyllites are phyllosilicates or sheet silicates. So phyllon or phyllon means leaf in Greek, and I'm going to use the analogy of a book's pages. This is quite a good one. It's going to come up throughout this. So the molecular structure functions basically as pages of silica molecules. So these sheets of silica molecules, hence why it's called a sheet silicate, which are bonded together laterally, kind of along the pages, but not vertically between the pages. So this is demonstrated by apophyllite's cleavage. A mineral's cleavage is essentially the mineral's susceptibility to splitting apart along specific planes. So cleavage planes are repetitive planes of weakness, which a mineral will split along when struck, or even potentially when just handled gently. So if you've ever handled mica or you've seen sheet mica, you can literally peel that apart along its cleavage planes. You don't even need to strike it or whack it particularly hard or anything like that. So other phyllosilicates include mica, serpentine, talc, and as I've said, apophylites. These are all sheet silicates, and they all exhibit this page-like cleavage where they can be easily flaked apart. So although apophyllite is stronger than mica, you can't physically flake it apart very easily with your fingers. It still exhibits quite strong cleavage, because if you would compare this to a quartz point, which quartz doesn't have a cleavage, if you can kind of think of it that way, if you've handled apophyllite or you've seen apophyllite, it often breaks along its cleavage planes, which are perpendicular to the termination points. So apophyllite is actually Greek for flakes off, which is another clue to its structure. So if we look at the chemical structure of apophyllite, I've already mentioned that it is a hydrated mineral, and the chemical formula notes the presence of water molecules sort of lingering around. So if you Google apophyllite chemical structure, you will see that there are 8 H2O or water molecules sort of hanging around at the end of the chemical structure after the dot. So this dot within chemical structures denotes that the water molecules are not actually bonded into the structure, They're not actually holding hands with the rest of the molecules in the group. They're actually trapped in between the sheets of silica. So if you if you think of this book analogy of these pages of silica, these water molecules are actually hanging around in between the pages, and they are helping to stabilize the structure. So the fact that they are there energetically on a chemical level is helping to stabilize the structure. So when apophyllite is heated, it actually starts to flake apart. So as I've said, apophyllite means flakes off. And as you heat it up, the water molecules, which are trapped between the silica sheets, are actually able to evaporate outwards. And as they were helping to stabilize the structure, when they're gone, apophyllite flakes apart really easily. So yesterday, I thought I would give this a go. I've read it about it online enough times now. And you can try this as well. If you have a small piece of apophyllite that you are willing to sacrifice. So I stress the word sacrifice because it will break up if you try this. It will break into little pieces. So please do not do this with a piece of apophyllite that you don't want, that you would mind breaking up into little pieces. I actually felt really bad. I love apophyllite. I have like maybe 10 pieces of apophyllite. So I chose the tiniest one that still had like discernible apophyllite points on it. And you can actually try and destabilize the crystal structure yourself. So I put my little piece of apophyllite into the oven at about 200 degrees Celsius for about 2.5 hours. It might have needed less time than this, but that's just how long I put it in there for after I tested it. And once it's been in there, allow the crystal to cool down. Again, I stress this, if you're doing this with kids or even yourself, allow the crystal to cool down after it's been in the oven. And then once the crystal is cool, you can handle it and feel how easily it starts to break up. So I pressed down on the points of apophyllite with my nails and they shattered, all of them. And they were shattering, they were cleaving or splitting along those cleavage planes, which, as I say, they run perpendicular to the crystal terminations. So yeah, you can try this at home if you're willing to give up a small piece of apophyllite or just a little point maybe. So onto the geology. So the best apophyllites on the market are from Maharashtra state in India, and they've come out of the Deccan Trap geological formation. So Maharashtra is in central West India, and it is almost completely composed of the Deccan Traps geological unit. The Deccan Traps are what's known as a large igneous province by geologists, which is an extremely big accumulation of magma and lava. The Deccan Traps themselves are absolutely huge. They are about 2,000 meters thick, and currently they are 500,000 kilometers square. So prior to erosion, they actually used to be 3 times bigger than that. They used to be 1.5 million kilometers squared, which is half the size of present day India. Their size was reduced by 2/3 due to erosion. So as erosive processes have come along, the actual size of them has been reduced by 2/3. But in comparison, the UK, the entire of the UK, is 250,000 kilometers squared, which is half of the current area covered by this single geological unit. That is really unusual geology wise to have geological units of all the same stone that have been produced during the same geological event be that absolutely massive. That is really unusual for us. I'm trying to stress at this point how how big they actually are. So the Deccan Traps are a very large stack of lava flows, and the name actually comes from the Swedish trappa, which means steps. So you can kind of see how, to a geologist, they somewhat resemble a massive staircase or a massive set of stairs. So how does a enormous formation like this actually occur? The Deccan Traps are formed from basalt lava flows, which are from a fissure eruption. So what is a fissure eruption? We have seen a really good example of a fissure eruption very recently in May 2024 in Iceland, where a fissure eruption has opened up on the Reykjanes Peninsula near Grindavik. And the fissures, it's basically a big crack in the ground or a big fissure that opens up very long. It can be, kilometers long, this fissure, and it allows very large amounts of lava to outpour all at once. If you can imagine all the way along this long crack, there's lava pouring out of it. This is a different type of eruption and also a different type of lava to the poster examples of volcanoes that you may think of. So there is no mountain with a volcanic vent at the top, which is like exploding ash into the sky, as you might imagine, with like Pompeii or Mount St. Helens. This is a much less viscous type of lava, so it's much more runny than in those eruption events, which is erupted out of just these cracks in the ground, and it is able to flow a very, very long way before it cools down because it is so runny. So the Deccan Traps outpoured around 66 million years ago at the end of the Cretaceous period, which is a geological period of time, and the outpouring is estimated to have lasted 800,000 years. So if we think of the amount of land that these lava flows took up, if that's hot, it used to be half of modern day India, it used to be 1.5 million kilometers squared, and it lasted 800,000 years. This is a geological event that we don't see anything like that. We haven't, we can't really imagine anything like that. If that happened today, that would be absolutely disastrous. And there would be very little we could do about it. You can't stop. There's kind of like mitigation measures. You can try and protect towns. People put up walls. People in Iceland, they put up barriers to try and direct the lava flows. But an event like that would be absolutely catastrophic. And this event actually occurred alongside the Cretaceous Paleogene mass extinction event. So this mass extinction event was an absolutely colossal event where 75% of all life on Earth, including all non-avian dinosaurs, died off. So this is widely accepted to have been caused by the Chicxulub impactor, which was a 10 kilometer plus wide asteroid which struck Earth just slightly north of the Yucatan Peninsula in Mexico about 66 million years ago, and it essentially saw an end to the dinosaurs. That is the dinosaur mass extinction event. The aftermath of the event meant that the debris and the ash that was sprayed up into the atmosphere, not enough light could get through this. The Earth cooled down and there was an impact winter, which is what we call when the food chain essentially collapses. So the food chains for life on Earth at the time collapsed, and they could not support many of the species on Earth at the time, including all non-avian, non-flying dinosaurs, and 75% of life on Earth died off. So, again, that's very difficult. We're observing slowly now an extinction event a lot. We have a lot of species dying off at the moment. But if you think 1 in 4 species survived that, so if 75% died off, that's 3 out of 4 species died off during that event. And all of the life we have on Earth now is descended from that leftover 25%, which is just crazy to think about. So how is this relevant to the Deccan Traps? So studies in 2014 and 2015 indicated the possibility that both the eruption event of the Deccan Trap lavas and the Chicxulub impactor played a part in this mass extinction event. So they are actually at antipodes to one another, which means that they are opposite each other on the globe. So, that whole thing about if you dug a hole all the way through the Earth, if you were at Mexico, you would come out quite near India on the other side. And scientists were kind of have sort of speculated whether all of the destruction that was caused by the Chicxulub impact, if any species could have survived on the other side of the Earth, if the fact that there was also that large igneous province forming on the other side of the Earth, that meant that it was much less likely, and all in all it made the situation a lot worse. Or there's other indications that the impactor actually caused or exacerbated the Deccan Traps eruption. So we have to think, geologically speaking, why did all of this magma well to the surface? Why was there this enormous eruption that lasted so long? Potentially it was the seismic destruction and the seismic havoc that was caused by such a massive asteroid hitting the Earth, that meant that this eruption occurred. So where are the apophyllites? Where are the lovely geodes that we get in the basalts themselves? So as I say, the lavas are basalt. Basalt is a very dark, fine-grained volcanic rock, which if you have specimens of apophyllite, a couple of my specimens, it will have the matrix on there, and you'll be able to identify it. It's the very dark rock that the crystals are growing on. And the apophyllite crystals and all of the associated crystals with apophyllite are found within the cavities and voids within the Deccan Traps. So these voids are there because lava is actually full of gas, which you don't really think about. You think of it being a liquid or a solid even, but it's full of gas. And when it's underground and is known as magma, this molten rock is under so much pressure that the gas is actually dissolved, and it's not able to form gas bubbles. And when the magma is erupted and can now be referred to as lava, the pressure is really suddenly reduced and gas is allowed to exsolve out of solution. So you can liken this to a bottle of Prosecco. When the cork is in the top of the bottle and the liquid is under pressure, there are no bubbles forming inside the liquid. However, when you pop the cork off, suddenly all these bubbles are forming out of the liquid. It becomes fizzy, and they're seemingly forming out of nothing. That's because the gas was previously held under pressure in solution within the liquid, and now it's no longer under pressure. The gas is able to exsolve. So this can be a really explosive process with Prosecco and with lava. And the vapors and the gases are, it can be water vapor, carbon dioxide and sulfur dioxide. Those are the three primary gases that will be coming out of lava. And they're forming bubbles. So as the lava cools down and solidifies, these bubbles will be left over as little cavities within the lava, within the cooled lava. So these are known as vugs, which is VUGS. Geologists know them as vugs sometimes, and they are on all scales. So on a tiny microscopic scale, you have absolutely tiny, tiny pore spaces opening up within the solidified lava. These are known as vesicles or vesicles by geologists. And then you have slightly larger ones. If you've ever used pumice, that rock that people use it to exfoliate, that is formed in this way. So those little tiny holes, those little empty pockets, are gas bubbles that have been left behind when the lava has solidified. And then all the way up through to, you can have absolutely massive gas bubbles, which are called lava caves. So big enough to stand up in, big enough to fit a car in sometimes, these massive gas bubbles that have accumulated. So these little gas pockets and bubbles of gas within the solidified lava or the basalt, they turn into our lovely geodes. So this happens through secondary mineralization through hydrothermal crystallization. So these little voids collect mineral-rich waters over the millions of years after the lavas have been formed, and that's when secondary mineralization occurs. So primary mineralization is what goes on whilst the rock is still molten, and secondary mineralization occurs after the rock has solidified. So after the initial crystallization has occurred and the rock has cooled down, this secondary mineralization is occurring within the rock, within the little pockets of gas or empty pockets now, within the environment that the initial rock has provided. So these voids are full of a mineral-rich cocktail whilst hydrothermal crystallization is occurring. So hydrothermal crystallization is essentially the idea that after, when you have these lava flows that have solidified, there will be waters moving through them. So I mentioned that water vapor is one of the primary gases that comes out of lava. So there will still be water down there, and there will be groundwater and things like that. So these waters will be moving through the rock, especially if they're full of pore spaces and bubbles. So if it's a permeable rock, there will be water moving through it, and they will be really rich in soluble mineral ions. So crystallization is going to start to occur under the right temperature and pressure conditions. These molecules will start to nucleate out of solution, and they will slowly link up with each other to build the organized and repetitive crystal lattice structure that we hear about very often. And these crystals will be built very, very slowly over millions of years. This is where those water molecules previously mentioned have become trapped between the silica sheets. So during that building phase, when these minerals are forming in an aqueous environment, they're forming into those layers, and because there's water all around them, a few water molecules are going to be left behind and trapped in that structure. Apophyllite crystals very often are sold with kind of their associated minerals that form within the same geodes, within the Deccan Traps, and that can include quartzes, zeolites such as stilbite and scolasite, calcites, heulandites. I've got some apophyllite that's got some analcime on it, which I think is another zeolite. And these can all be sold together. So you might have an apophyllite specimen, and there's also some pinkish bits on there, and that might be stilbite. And there's also some druze on there that is quartz, or some chalcedony, which is still quartz. And they're all forming together in those pockets. So it often happens, actually, I've been asked before how, and when I did this talk, I tried to demonstrate, how do you tell the difference between clear quartz and apophyllite? Because it can be a little bit difficult, especially if they're being sold together. They can look quite similar, especially if you've not tried to identify the difference before. So I mentioned earlier that apophyllite has its four-sided prisms and symmetrical four-sided pyramids as its terminations. So that's because it is a tetragonal crystal. So it grows within the tetragonal crystal habit. And that's really distinctive. So quartz, on the other hand, is that quartz grows with six-sided points, and it doesn't have those four-sided symmetrical pyramid points. So if you have any next to each other, that's a really good way of being able to tell them apart. So the apophyllite samples are actually extracted from the basalt quarries by dynamite blasting. This exposes new faces for the geodes to be extracted out of. The geodes are extracted, the excess basalt is trimmed off of the outside of them because it's a lot of weight for something that's not very valuable to ship that around the world. And then the crystallized material is then exported out of Mumbai, and then it's onto the crystal wholesale market. And that is probably where you have managed to get your hands on it, if you have some. And it is a very popular crystal for metaphysical practice. So apophyllite is believed to be soothing and enlightening. It is very strongly associated with the crown chakra. I come across that very, very often, that it is closely linked to the crown chakra. And it is thought to signal to the universe that you are ready to begin your path into spiritual enlightenment. So this quote, which I'm going to finish on, which I really enjoy and have shared before, is by Robert Simmons, and it's in the Book of Stones, which is a very popular and very useful crystal book if you're looking for that sort of thing. So this is the quote. Scientists can view matter as lifeless and without consciousness. Once apophyllite has lifted the veil, one sees the world, both inner and outer, as alive and filled with intelligent awareness. And I can remember the first time I read that quote, it was last year, it was late October-ish last year, when I was preparing for the London Gem and Mineral Show last year, which is where I first did this apophyllite talk. And I was like, I mean, I still am a baby on the crystal journey, but I was really, really, really a baby at that point, and had I come at it from being a geologist. Obviously, that's my specialty, is I'm a geologist. And I remember reading that quote, and I'd been really drawn to apophyllite, actually, but I worked in crystal wholesale for 2 years, right up until just before the Gem Show last year. And I had always been really drawn to apophyllite and had always wanted to buy pieces of it and collect pieces of it. I'm literally, as I record this podcast, I'm sat looking at 2 different pieces of it, which I've bought. And I just really enjoy it. And I was beginning to experience this interaction between the end of the spectrum of people who enjoy crystals, who are the metaphysical healers and very much on the holistic side, and that's what they know the most about. and they don't know as much perhaps about the geological side. And I was coming at it from the perfect opposite end of the spectrum, the total opposite end of the spectrum, which is from the geological side. And I was, trying to learn more about the other side of it, about the holistic side, and was just completely, just meeting people in the middle somewhere for the first time. And I remember reading that quote and it just all clicking into place and really enjoying it. So yeah, maybe that speaks to someone out there. I hope you have enjoyed today's deep dive into apophyllite. If you did enjoy this episode, as I say, please follow and rate this podcast. And you can find me on social media under @CrystalCaseStudies. My name is Emily. It has been a pleasure, and I hope to see you again.